Okay, guys, good to speak to you again. I hope yesterday went well. I have to say I've been extremely impressed with the work you've submitted in maths yesterday, and if we could keep up that level of work for the rest of the half term, we're going to do some fantastic things. Okay, so keep it up and just keep working hard. I would just like to just quick note again about where you need to put your work. A lot of you are now putting it in the right place, which is fantastic, but still a few people still need to just have a look. Now Anna's done it perfectly again. If I go into Anna's page, yesterday was similar shapes, and she's put her work into the similar shapes, and it is absolutely perfect. Expect anything less. Well done, Anna. And then what she would do today, I've created a new page for her today, and that's today's date, similar shapes, area and volume, and she just needs to upload her work into there. Now, you will get quicker and quicker uploading work. I want you to do this every lesson just so you've got a record of what you've been doing. So well done on that yesterday. I can see a lot of people doing that effectively. Great. Right, okay, so if we go back to the lesson, so we're going to start straight in with the content today, and I am going to disappear now. So I will see you again. I think I see you on Friday. So I'll see you on Friday. And hope today goes well. Remember, I'm on the email if you have got any issues. Okay, all right, guys, here we go. Right, okay, so today we are continuing with similar shapes, but we're going to look at, so today's date is the 23rd, but today we're looking at area and volume of similar shapes. Area and volume of similar shapes. Okay, we're going to focus on area today, but we're going to start volume. I'm going to do volume next lesson as well. Right, okay, so it's obviously important you copy these notes down. Again, if your exercise book has run out, please try and get a new book. Get your mum to order you one in, or order one in yourself, or use paper, that's fine. Right, okay, so if we've got a square, got two squares here, and I'll say the length of that square is 2, the length of that square is 4 meters. Now, obviously, the length scale factor to get from the small one to the big one in terms of length. Now, length scale factor I'm going to call as LSF. That means the length scale factor. You simply times by 2, wouldn't you? You double to get from the small square to the bigger square. You times by 2. Now, area does not work the same. Now, the area of this small one is 4 meters squared, isn't it? 2 times 2. The area of the bigger one is 16 meters squared. So for area, you would not times by 2, and that's a lot of people do fall into that trap. For the area scale factor, you times by, well, in this case, 4, don't you? Times by 4. Now, what it actually is, you're timesing it by 2 squared, which I'll explain in a minute. 2 squared is 4, so you're timesing it by 2 squared. Now, if I was to make this a cube, let's make it 2 big cubes here. Okay. Now, the volume scale factor, well, what the volume of this one, volume of that cube would be 2 times 2 times 2, 8 meters squared. The volume of this one would be 4 times 4 times 4, which is actually 64 meters squared. So it's certainly not double. It's not even 4 times bigger. It's actually 8 times bigger, isn't it? It's 8 times bigger if you've got a volume. And what you'll find is that is times by 2 cubed. Okay, so now that's really, really useful to know. This example is extremely important. If you're comparing areas, you don't just times it by the length scale factor. That's one of the biggest problems I see from GCSE students is that's what they do. Okay, now this little box underneath will help you. So if you've got the length scale factor, which was our first one, we're comparing lengths. That was our length scale factor, 2. We times it by 2. The area scale factor would be the length scale factor squared. Okay, so you square the length scale factor. That gives you the ratio for areas. And the volume scale factor is the length scale factor cubed. Okay, so that box there is very, very useful to note down, and we're going to use that in a minute. Okay, right, let's look at a couple of examples, and then you're going to be doing some work on this. So easy one, we're only going to be looking at areas today. Tomorrow we'll look at volume and also a few harder questions as well. So, right, imagine I've got two similar shapes. They have to be similar for this to work. Don't look particularly similar, but let's just imagine they're similar. And the length of that one is 5 meters, and the length of that one's 15. And we know the area, it tells us the area there is 20 meters squared. Let's say that's shape A and that's shape B. So find the area of shape B, could be the question. Okay, now I'm going to start with a common error, and you can probably expect what it'll be. Common error, what people do say, okay, to get from the small to the big, I times by 3, okay, because 5 to 15 you times by 3, don't you? So common error, okay, I must do just 20 times 3. And that is a disaster, 0 marks, so don't fall into that trap, okay? What you should do is, okay, I'm just going to put it up here again just to give us a bit more space. So the length scale factor is times by 3. The area scale factor would be times by 3 squared. Okay, times by 3 squared, that's really important. So my actual answer is going to be 20 times 3 squared, because I'm looking at areas, not looking at lengths. And 20 times, well, that's 20 times 9, 180 meters squared would be the correct answer. Okay, so don't fall into that trap. Okay, right. The same would work if you were to go backwards. If you were to go backwards, you would times it by the area length scale factor squared, and that might be a fraction. So EG2, let's look at a second example where I'm given areas. So I've got a cylinder, okay, another cylinder. They're similar cylinders. They have to be similar for this to work. And the surface area of this one, the surface area is 300 meters squared, and diameter is 9 meters, okay, and I'm going to call that shape B, and I'm going to call that shape A again. And I know the diameter of this one is 6 meters, and the question might be find the area of the cylinder A. Okay, find the area of the cylinder A. Well, the same rule applies. So to get from the big one to the small one, I times by 6/9. 6/9. I might want to simplify a little bit. That's the same as 2/3, isn't it? 2/3. This could be in a non-calculator paper, quite possibly. So that's the length scale factor. Therefore, the area scale factor would be times by 2/3 squared. Yeah, 2/3 squared. So I'm going to do 300 times 2/3 squared. Well, that's the same as doing 300 times 2/3 times 2/3. Okay, remember this could be in a non-calc. Now, at this stage, I'm fully within. I could either times along the top, or I can start cross-cancelling the bottoms if I want to. So I might just tidy this up a little bit. 300 over 1 times 4 over 9. This divides by 3, and that divides by 3. And I will end up with 400 over 3 meters squared. And that is fully acceptable as a fraction. That's fully acceptable unless it says round it to a decimal place. Okay, right, that's all we're going to do today in terms of notes. I have set you some Hegarty work on this. So your classwork today is Hegarty work, and upload workings to the correct page, please. There's still a few of you who didn't put it onto the right page. It's important you put it onto the correct page so all your work is really nice and neat, especially if you're using paper, because so it doesn't get any lost. Okay, right, good luck again, and I'll speak to you again on Friday. Well done, guys.